everyone. Welcome to this channel. Today we'll discuss an important topic, the theory of probability. So it is important for the students of economics. So in this video we'll discuss mainly some concepts, terms, and definition of probabilities. Before understanding probability, some terms frequently used in the theory of probability has been discussed for clarifications. First is trial. Now, what is a trial? When an experiment is repeated under same conditions, then it results in any possible outcomes. Then the experiment is a trial and outcomes are known as events. So the experiment should be repeated under same condition. So first we have made a trial. Then in the second trial we should not change any environment or any setup, but it should be same conditions. Similarly, the following trials should also be conducted under same conditions. Then there will be outcome of the trials, and outcomes are known as the events, and experiments are known as trials and outcomes are known as events. For example, tossing a coin, it is a trial. The turning head or tail of the coin is an event. Then equally likely cases. So every result of the trial has equal chance of appearing. So equally likely cases that when we have done any experiment, the outcome, there will be no conflict of outcome, that outcome 1 has come, so outcome 2 cannot come, no. So equal chance, equally likely cases. For example, tossing of a coin and getting head or tail has equal chance. So a coin has head or tail. So when you toss it, either head will come or tail will come. But there is no restriction that when head comes, tail cannot come, no. So they are equally likely cases. Then mutually exclusive cases. It is incompatible that such events cannot happen at the same time. It is called incompatible. So the events cannot happen simultaneously, cannot happen at the same time. They are mutually exclusive cases. Best example is from a deck of 52 cards. In a single draw, suppose you have drawn king, but the queen at the same draw, queen cannot come. Either queen will come or king will come. So if king comes, so queen cannot come in the same draw. So getting king or queen from 52 decks in single draw is not possible. So both queen and king and queen cannot come at the same time. So they are known as mutually exclusive cases. So it is called, it precludes the occurrence of the other. Then exhaustive cases. Exhaustive cases, it includes all possible cases. In tossing a coin, turning up of head and a tail is exhaustive case. Both do not occur simultaneously. So, in this case also, the both head and tail cannot come simultaneously. So, it includes all possible cases. Then favorable case, it entails the happening of the event. In tossing a dice, getting multiple of 3 is 3 and 6. The favorable cases are 2. Suppose we have toss a dice, getting multiple of 3 is 3 and 6. So either it must be 3 or 6. So multiple of getting 3 is 3 and 6. So favorable case is 2. 3 and 6, 2. Multiple. So under, so 1, 2, 3, 4, 5, 6 surfaces are there. So multiple of 3 is 3 and 6. So favorable case is only 2. This is a favorable case. Now, with this background of terminology, some terms, let us have the definition of probability. There are two definitions. One is mathematical definition and another one is statistical definition. So in mathematical definition it is said, if there are n exhaustive, mutually exclusive and equally likely cases, you see we have already discussed those terms, exhaustive, mutually exclusive and equally likely cases, n number of cases, and m of them are favorable to an event A. So, say event A, favorable case is m out of n. The probability of happening of A is the ratio of m by n. So what is the probability of happening A? M divided by n. N number of exhaustive cases, n number of cases, and m of them are favorable case. So m by n is the probability. It is written like this: P is equal to m by n. P is a positive number and its value is less than 1. So probability is always less than 1. It cannot exceed 1. So that P ranges between 0 and 1. Then probability not happening. So this is the probability of happening. Probability of not happening is that is Q. Not happening is n minus m divided by n. N minus m divided by n. So m happens, so n minus m not happen. It means Q. So this is equal to, if we simplify, it is equal to 1 minus m by n is equal to 1 minus p. So m by n we have got p. So it is 1 minus p. So p plus q, this is the value of q, and p plus q is equal to 1. So it cannot exceed 1. Probability of happening and probability of not happening, if we multiply, it becomes 1. Now there are certain limitations. Limitations is not clear in the theory. Number 1, what will happen if the cases are not equally likely? So if cases are not equally likely, then what will happen? There is no answer. Then number 2, if total number of possible outcomes is infinite, the classical definition fails. If total number of possible outcomes is infinite, there is no limitation of the outcomes, necessarily the definition will fail. So indefinite outcomes. It may not be practically possible to enumerate all the equally likely cases. So this is another limitation, that practically it may not be possible to enumerate all the equally likely cases. Okay. Now the statistical definition. If trials are repeated a great number of times under essentially the same condition, you see, the trials, it is such that in the statistical definition it is said that if trials are repeated many times, great number of times, under the same condition. The condition, as I said earlier also, condition should not be changed, otherwise the results, events or outcomes will change. So under the same condition, then the limit of the ratio of the number of times that an event happens to the total number of trials, as the number of trials increases indefinitely, is called the probability of happening of that event. So when it is done under the same condition, then in statistical definition they have put the limit. So limit of the ratio of number of times that the event happens. So what is the what will be the ratio? One will be the number of times that the event happens with the indefinitely with the trials, and number of trials, increased number of trials. So if we take m is equal to number of times in which the event A happens, then n is a series of trials. So in series of trials, there is no limit that 5 trials or 6 trials or 10 trials, there is no limit. In a series of trials, if m happens, m number of times in which the event A happens, then probability of A is equal to P is equal to limit m by n when n tends to infinity, because there is no limit of the trials, it is indefinite. So f, then a set of trials, there is series of trials in indefinite. In that case, the number of times the event A happens divided by the series of n trials. So this ratio is the probability. Is the limit must be finite and unique. So in the mathematical definition and statistical definition is almost same, but in statistical definition they have put the limit of the number of that means trials. They have put limit in the number of trials. So but ultimately, if we see simply, if we have to remember, simply the number of times it occurs divided by total number of trials. This is the probability. This simple, we should remember that this is happening, and out of this. And in statistical definition, they have put that n is the infinite. That means large number of trials. That's why they have put it infinite. There is no restriction that it must be 5 or it must be 10. No, it is infinite. When large number of trials. That's why I have put infinity. So this is this is all about the mathematical and statistical definitions. And thank you very much. Keep on watching. It is an interesting subject. We'll discuss in more details. Thank you. Please share.